To begin the discussion on modern atomic theory, we start with John Dalton back in the early 1800s. He developed the first atomic theory and is therefore considered the father of modern atomic theory. He was one of the first scientists to conduct experiments and collect data. He then developed a solid theory based on the inferences from his experiments. Working with gases, Dalton was able to develop what is considered to be the first atomic theory. The theory has 5 main points. Here they are. All matter is made up of atoms. Atoms of a given element are identical. You cannot break down atoms. Atoms combine in whole number ratios to form compounds. Atoms rearrange during chemical reactions to form new compounds. Now, these points have stood the test of time, but there are a couple that have been disproven due to scientific advancement since the 1800s. So, is matter still made up of atoms? Yes, that one is still true. Are atoms of an element identical? No, they are not. We have isotopes, atoms that have the same number of protons but different numbers of neutrons. Okay, can atoms be created or destroyed, or do they have smaller parts? Yes, they do. A nuclear reaction can break atoms down, and we know that atoms are made up of smaller parts, protons, neutrons, and electrons, and even smaller yet, quarks. Do atoms still combine in whole number ratios? Yes, they do. Do they break apart and rearrange to form new compounds? Yes, they do. So 3 out of the 5 postulates are still accepted today. Dalton believed that atoms were small, indestructible spheres which somehow had the means of physically hooking together. He believed atoms of the same element were identical, but different elements had different sizes. Dalton was limited by his place and time. For the knowledge and resources he had, he created a solid atomic theory. Another limitation came from a 6th postulate which was known to be incorrect. This postulate prevented his atomic theory from gaining credibility in the scientific community. One piece of technology that was being developed around the same time as Dalton's atomic theory was electrolysis. There is no doubt that some of the knowledge developed from electrolysis could have been used by Dalton in his atomic theory if he was aware of it at the time. Electro means electricity. Lysis means to break apart. So electrolysis literally means to break apart a chemical using electricity. We covered electrolysis in Honors Chem, and we will cover it again later, but I'm going to go through it quickly here using the electrolysis of copper sulfate. So if you have a beaker of copper sulfate solution, we know that the copper sulfate exists as Cu2 plus ions and SO4 2 minus ions. Now if you put a piece of copper metal in the solution and connect it to the positive terminal of a power supply, you create the anode. Then take another piece of copper metal and connect it to the negative terminal of the power supply, and you create the cathode. If you turn the power supply on, current will run through the circuit from the anode to the cathode. For example, copper metal at the anode will give up 2 electrons and become copper 2 plus ions. The electrons move through the circuit, and the Cu2 plus ions go into solution. The electrons build up on the cathode, giving it a negative charge. Now opposites attract, so the Cu2 plus ions in solution will move to the cathode, pick up 2 electrons, and become copper metal. This is electrolysis in a nutshell. So, what the heck does electrolysis have to do with atomic theory? Electrolysis proved that there is some type of chemical charge associated with atoms. Maybe atoms are made up of smaller things that have charge associated with them. Also, it led to the discovery of many new elements. It proved that many substances that were thought to be elements were actually compounds, most notably water. Water was thought to be an element, but electrolysis proved that it was actually composed of hydrogen and oxygen. These metals, listed at the bottom, were also discovered using electrolysis.